Did you ever wonder how fast a fan rotates? You know, how many rotations it makes per second. Well, in this activity, we're going to answer this question by using two different measurement techniques:
a light sensor and a sound sensor.
Each of these techniques is based on a different physics concept. Let's start with the light sensor. In this experiment, we'll need a NovaLink data logger and the Multilab software, a triple-range light sensor, a flashlight, and the star of the show, of course, a fan. So first, let's set up the sensor in Multilab. Set the light sensor to 600, and then set the sampling rate to 500 samples per second and the number of samples to 10,000. Turn on the fan and wait until it reaches a steady speed. Make sure the room is as dark as possible, and then turn on the flashlight and position it so it's shining perpendicular to the rotating blades. On the other side of the fan, hold the light sensor so that the light from the flashlight will go directly into its eye. Begin recording in Multilab and measure for several seconds. The graph shows the modulation of light intensity over a few seconds. Now, we'll zoom in and mark two peaks. The first, an arbitrary peak with the left arrow, and then the third peak to its right. But why do we count 3 peaks? Well, let's take a look at the fan. It has 1, 2, 3 blades. Over a single rotation of the fan, we would expect the light intensity to oscillate, or go up and down, 3 times. Now let's look at the formula below the graph. This gives us the time during which we see these 3 peaks, and it's a very good estimate for the frequency of the fan. Now let's confirm our results using another method. Why believe just one?
This time, let's use a sound sensor.
We won't need the flashlight for this part. Okay. Now make sure the room is extra quiet before starting.
And connect the sound sensor
And use the same logger setup as before. As such. Turn on the fan and wait for it to reach its maximum speed, and then measure the sound that the fan produces over several seconds. Now stop recording. And turn off the fan. The graph of the measurement will look like this. Now we'll zoom in and once again figure out the time during which we see these 3 peaks. The time interval is 0.064 seconds, which translates into a frequency of 15.6 Hz, only 3% deviation from the light sensor method. Well, I don't know about you, but I'm a huge fan of this experiment.